Hey, what's up? In this Blender tutorial, we're going to model a piece of IKEA furniture and put it in my office using FSpy, Blender, and Photoshop. We're going to cover several techniques to combine a photo with a digital model at real-world scale. So let's get started. I'm going to start by taking a photo of my office. If you want to follow along, you can download the same photo from the link in the description. Or you can make it a little bit more personal by taking a photo of your own space. I always recommend doing your own unique version instead of following along exactly because you'll remember more of the process. We're going to use the free add-on FSpy to digitally match the camera in Blender. We're also going to use it to model the IKEA furniture accurately so that everything's at scale. Before we begin, open up Blender and look at the workspace. There are three main axes, the red x-axis, the green y-axis, and the blue z-axis. When matching perspective using the FSpy add-on, we're attempting to identify these axes as they exist in the photo. This technique assumes that everything is square at 90-degree angles, but newsflash, asshole! Things in the real world often aren't. It's not an exact science, so do the best you can. In general, photos with two clear vanishing points work better than straight-on views, and I try to keep the vertical edges straight up and down rather than tilted. It's just a personal preference, but sometimes you also just have to work with what you have. Open FSpy and import your image. Uncheck Dim Image to make it a little bit easier to see. Grab the red handles and align them with the edges that represent the red x-axis. Hold down Shift to temporarily zoom in. Do the same with the green handles for the green y-axis. Try to choose areas of high contrast. Most of the time this produces a good enough result, but check the vertical edges and see how they align with the blue z-axis. If you want more control, change the principal point from image midpoint to from third vanishing point. Now you can align the blue handles along vertical edges to identify a third vertical vanishing point, which is where the vertical lines will converge to. Sometimes the gizmo will be upside down, but you can flip it upright by changing the x to the negative x under vanishing point axes. Save your file and name it something intentional like office, not something generic like image 7230. In Blender, make sure that FSpy add-on is enabled under Edit, Preferences, and Add-ons. If you don't have it, go to the FSpy GitHub page, download the zip file, and install it. Go to File, Import, FSpy, and find the file that you've saved. Several things have happened in your scene. You now have a new active camera object in your scene. From this camera view, which you can see by pressing 0, you can see the global X, Y, and Z axes of your Blender scene align with the FSpy setup, and the cube moves as if it was aligned with the walls of the room. If you select the camera and go to the Object Data Properties, you can see it has a background image, and the image name is your file's name .fspy, in this case office.fspy. If you go to the Image or UV Editor and open up the drop-down menu, you can see this image is now embedded and accessible in the Blender file. This is going to be useful if you want to texture parts of your model using the image, which I'll show you how to do later on. In the Output Properties, you'll see the resolution has been changed to the size of your original image. And lastly, if you go to Scene Properties, you'll see the units will be set to metric using meters. This is important to note because my default scene is set up using inches, so anytime I bring in an FSpy camera, I have to make sure to reset the units back to imperial. I've measured this room and I know for a fact that the width of this wall is 144 inches by 94 inches tall. I'm going to model a plane of that size to use as a reference when placing the camera. Make sure the bottom edge of the wall plane is aligned at a Z value of 0. The first thing I check is the camera height. I hold the camera about 66 inches off the ground, so I want the FSpy camera to be the same height. Sometimes I work from screenshots taken from Google Streets, and those cameras are usually much higher because they're on top of a car, so you have to account for that. Again, it doesn't have to be exact, but it helps to be somewhat realistic because the vantage point is going to be different. Cameras are like physical objects in your scene, so you can move them around like a real camera on a tripod. I want to move the FSpy camera so that the wall in the photo aligns with the plane that I created. You can select and go into the camera view by pressing 0, and then move the camera with G to grab, and then X or Y to move it in the X and Y directions. Another way to move the camera is pressing G and then Shift Z, which will lock the Z value, so it can be moved around in the XY plane without moving up or down. I don't often do this, but you can also create a quad viewport in your 3D viewport by pressing Ctrl-Alt-Q. You can set the perspective window to be the camera view, and then use the top view to move the camera around until it matches. If you hold down Shift during a transform, it will slow down the movement for fine-tuning. As a reminder, Ctrl-Alt-Q will also revert the quad viewport back to a single viewport. And yet another way to position the camera is to use the walk command, activated by pressing Shift and tilde. You can use W, A, S, and D to position the camera, but make sure not to move the mouse as that will change the camera's rotation and cause misalignment with the global axes. This photo has some furniture that I'll need to get rid of in order to show the IKEA furniture as a replacement. If your photo has nothing there, it's a little bit easier, but here are some tricks to make these desks and chairs disappear. To do this, I'm going to recreate part of the room digitally. I'm going to model the walls, floor, and ceiling, and use the photo of the room to texture the model of the room. The room is pretty much a box, so I can just extrude the plane that I created for the wall. I want the floor, walls, and ceiling to be separate objects, so I select the face of the floor and press P to bring up the separate menu, and then S to choose selection. Do the same with the ceiling, select it and press P to separate, and S for selection. In object mode, right-click and reset the origin to geometry for each of these 3 objects. Something to note, when you separate something into a new object, it will retain the origin of the original object. I reset the origins to geometry often enough that I've added it to my quick menu for convenience. Press Ctrl R to create a loop cut and align it with the white base, which will run around the entire perimeter of the room. Double click towards the side of a face to select the loop of faces. Press Shift D to duplicate it, right click to reset the position, P and then S to separate the selection into a new object. Tab back into object mode and select the new object, and in edit mode press A to select all, Alt E to bring up the extrude menu, and choose extrude along normals. The normal direction means perpendicular to the face. Press S or hold down Alt to ensure an even thickness and type in 1/2 inch. That's one way of modeling the white baseboard. It's quick and good enough for what I'm demonstrating, but there are better ways to more accurately model that if it's important to you. When you're working, you'll constantly be making decisions of quick and dirty solutions versus time-consuming but more accurate solutions. It's up to you to decide how detailed and accurate you want your model to be and how much time you want to spend on it. It'll also depend on your situation and what you're trying to accomplish. In general, I try not to spend time on things that won't show up prominently in a final image. But if you're trying to just practice techniques and learn, you can take your time and learn through repetition. You can also use loop cuts to align with the window and delete that face to create an opening. The walls currently have no thickness, so you can select all faces with A, press Alt E to bring up the extrude menu, and select extrude along normals. Again, just like with the base, make sure to press S or hold down Alt to make sure the extrusion has an even thickness and enter something like 6 inches. The next thing would be to add lights, preferably to match the scene lighting. There are 2 lights in the ceiling casting a parabola or scallop of light on the wall. I can recreate those with area lights. Press Shift A and select area light. Press 1 to go into the front view and place it just under the ceiling. Press 0 to go into the camera view and place it to match the location in the room. Use Alt D to create an instance or a linked duplicate of the light for the second light. Under the light's object data properties, change the shape from rectangular to disk. Switch it to rendered shading mode and increase the power to create a similar shape on the wall. Lights in houses tend to be a little bit warmer than a standard white light, so you can shift the color to be a little more yellow or orange if you want. There's a window and exterior light, though the sunlight isn't coming directly into the window. You can add an HDRI light to achieve that in the World tab of the shader editor. Add an environmental texture, select your HDRI image, connect the nodes, and reduce the strength to like 0.6 or 0.7 from 1. This is kind of an optional extra step. You don't really have to do this for the final image we're making, which will be a combination of the photo and the model. But it's good practice to set up environmental lighting in all of your scenes. Also, if you wanted to completely recreate the room, you would want to match the lighting as closely as possible, or else shadows may not match and you'll notice it. In the shader editor, create a new material and call it Office Wall. Add a new texture image, connect the color to base color, and choose FSpy as the image. This is a reminder that the photo is available to use in Blender because it's the background image of the FSpy camera. Tab to go into edit mode, A to select all, U to unwrap, and choose Project from View. The photo has been projected onto the face, but it's pretty wonky. To fix that, you need to add more geometry with loop cuts or subdividing the faces. You could also add a subdivision surface modifier set to simple, but we're not actually going to do either of those. In the UV editor, press A to select all and then S to scale and 0 to scale the UV map to a single point. For the wall paint color, I can use the UV map like an eyedropper and choose a single pixel of the photo as the color. You can see as I move the condensed UV map around the UV editor, the entire wall is changing color. I can move it to a darker area in the shadow if I wanted to see what a darker paint would look like, or even to the yellow cushion if I wanted to see what that looks like. I'm just going to choose an area that appears approximately the same as the photo. I use this technique sometimes when I'm comparing paint colors. You can create a small paint swatch texture out of real paint colors and quickly swap out the color by simply adjusting the UV map. A lot of people criticize renderings as being too perfect to be photorealistic. This may be controversial, but I think photorealism is completely overrated. While it's true the real world does have imperfections, I never strive for photorealism just for the sake of it, especially if it requires a lot of extra work. In professional workflows, you don't have the luxury to dedicate extra time and effort to add intentional imperfections. No one's going to care about the fingerprints on your doorknob. Your energy is better off spent making sure material finishes and design decisions are accurately represented. Is light reflecting and behaving correctly? Are glossy and matte or textured materials shown accurately? Is everything correctly modeled at an accurate scale? These are more important questions to ask than does it look like a photo. So with that said, in my case, my wall and ceiling fixtures actually are quite textured, so light is affected quite a bit and the surface is not perfectly flat. So I'm going to take the time to give the wall and ceiling some surface imperfections, but again, because it's a conscious decision. I've downloaded this seamless eggshell texture that I'm going to use as a bump map for my wall. Giving the wall a bump map will create surface irregularities that will scatter light more realistically. In order to do this, I'm going to create an additional UV map. Under the Mesh's Object Properties, find the UV map menu and press the plus button to add a second UV map. I'm going to rename the original UV map to be wall color and the second map to be eggshell texture. Back in the shader editor for the office material, I'm going to add a UV map node and input that into the image texture node, which feeds the diffuse slot. I want to set up another UV map which feeds another image texture which goes into a bump map, which will go into the normal slot of the principled BSDF node. If you're new to the node system, you have to think of it as like a logic system that flows from left to right. There are certain types of node inputs and outputs that are certain colors, and you can only pass information through similar colors. For instance, the color output for the image texture node is yellow and can be passed into the yellow input of the principled BSDF shader. The purple output of a UV map node can go into the purple vector input of the image texture, because the UV map determines or drives how the image texture is going to be applied to the object. I'm going to use that word drive to describe how nodes affect each other. I'm not sure if that's the best way to describe it, but it's how I imagine it in my head. Once you start getting more complex node setups, all the strings and relationships can get a little confusing, but it's actually not as scary as it looks once you get used to it. To a beginner, this may look super complex, and to a more experienced user, this may appear super simple. There are ways of grouping and organizing nodes to make it a little clearer, but I don't use them because I don't really do super complex setups. You can use some of the same basic commands like G to grab, Shift-D to duplicate, and S to scale. Scaling doesn't increase the size of the nodes, but it does increase the space between the nodes to help see the connections and what's going on. Conceptually, before we get to editing the actual UV maps, we're going to use one UV map called wall color to drive how the image Office FSpy will be applied to the material's diffuse or albedo slot, which is essentially the color. Remember, this is the condensed UV map that we scaled down to 0 that's acting like an eyedropper and applying color based on a single point of the image. A second UV map called eggshell texture, which can be scaled and adjusted independently of the other UV map, is determining how the image eggshell is going to be applied to the material's normal slot. This black and white eggshell image will feed into the height slot of a bump node. The black and white areas represent high and low spots where the material will appear to be raised or lowered. If you're new to Blender or the node system, you can copy exactly what I'm doing, but it's important that you try to understand the concept of how the nodes work as well. Select your wall object and go to Object Data Properties, and under UV Maps, select the eggshell texture and turn the visibility on with the eyeball. In the 3D viewport, tab into Edit Mode, A to select all, U to unwrap, and select Cube Projection. Now you'll see the eggshell texture applied as the normal data on the wall, which gives the surface the appearance of irregularities. You can adjust the strength of the effect in the shader editor. There's a slider on the bump node for strength, and you can either type in a lower number, or I usually click and drag to adjust. Again, if you hold down Shift while dragging, it slows down and you can do a finer adjustment. If you select a node and press Ctrl Shift left click, you can quickly connect it directly to the material output node. Now you can see how the black and white image is being applied. And then if you reconnect the principled BSDF node, you can see the bump effect on the final material output. It looks like the wall has a little textured raised areas, but the wall is still a flat plane. If you think the scale scale of the texture needs to be adjusted, you can open the UV editor and scale the texture from there to be larger or smaller. Note that the color of the wall is not changing, only the bump texture. Because we set up 2 UV maps, these can be adjusted independently. If you select the wall color UV map and make it visible with the eyeball command, you can see that as I adjust the UV map in the UV editor, now only the wall color will change and the normal will stay the same. I'm going to do a similar thing, hopefully much quicker, for the ceiling texture. The ceiling's more of a stucco finish than an eggshell, but the same principle applies. I'll use this separate texture called stucco. Select the ceiling object, and I'm going to set up multiple UV maps under the data properties, one called ceiling color and one called stucco. UV maps are unique to each object, so if you have a material setup that is trying to access specific UV maps, your object has to also have those UV maps. I'm going to duplicate the material by clicking on this icon in the shader editor and rename it ceiling. Instead of wall color, I'm going to choose ceiling color. And instead of eggshell, I'm going to choose stucco. And now the ceiling is similarly set up to have multiple UV maps to drive the color and the stucco texturing. The floor will be a little trickier because there are a lot of objects in the scene like the couch, table, desks, and chairs that are interfering with the floor tile texture. I'm going to right click and select subdivide to increase the mesh density of the floor, project the texture onto the ground, and separate the parts that are the areas of just floor tiles. I don't want any part that has chair or table or desk in it. Delete the rest of the floor and duplicate and arrange the remaining pieces to make a repeatable pattern. You can either continue to duplicate this mesh to make a larger floor or apply an array modifier to expand the size. And now the room in our model is empty of existing furniture and has a textured floor, walls, and ceiling. Make sure to save your Blender file after this so you don't lose it in the crash. So now that the camera is set up, we can use FSpy in a similar process to model the IKEA furniture. IKEA's website has everything you need to create your own 3D models. IKEA also has these dimension drawings available for their products, so you can model from those or use them as reference as well. Go through the same process of matching your IKEA product rendering in FSpy. Align the red, green, and blue handles with the corresponding edges of the model. Save it as the product name, in this case Billy Bookcase. Import it into a new Blender scene, block out the approximate size based on the dimension drawings, and align the camera with the blockout. Don't forget to change the units if needed. Model the bookcase from the perspective of the photo, adding and editing new geometry directly from the camera view. You can model this as separate objects, but this works best when they join them into one object at the end with Ctrl-J. When you're done modeling, create a new material and call it Billy Bookcase. Add an image texture, and for the image, select billybookcase.fspy. Remember that this image is now already embedded in the Blender file as the background of the FSpy camera. Apply the material, and in edit mode, press A to select all faces, U to unwrap, and choose project from view. This is a quick way of texturing your model using the photo of the model. Since you modeled from the camera view and then projected the UV map from the camera view, they should align pretty well. Sometimes you may need to tweak the UV map a little bit, but for quick visualizations, this works pretty well. And you can always go back and create new materials that you like better. If you're smart, you'll take this opportunity to save it as a 3D asset in your asset library. In the outliner, right-click your bookshelf object and select Mark as Asset. When you save the bookshelf model, make sure it's in the Asset Library path, which can be set in Edit, Preferences, File Paths. Now you can quickly drag and drop it into scenes. Go back to the Office model and open up the asset browser. Now you can drag and drop the bookshelf directly into the scene. You can also just copy and paste it from one Blender model to another, but I'm just demonstrating how the asset browser works and one of the ways it can be used. And now you can render your scene. Once that's done, we can combine or collage the rendering with the existing photo in Photoshop, or a free version like Krita. Open your photo and bring in your rendering on a separate layer. The resolution of these images should match exactly because of the setup that we did in FSpy. I combine the images by using a layer mask. Layer masks are used to selectively hide parts of a layer, like a mask is used to selectively hide parts of your face. White indicates areas where the mask will be visible, and black will be areas that are hidden. When I add a new layer mask, the entire mask is white and the entire rendering is visible. If I invert it to black, the entire rendering is hidden. This is where the magic happens. If I use the brush tool by pressing B and make a large, soft white brush, I can paint the areas of the image that I want to show. In this case, the wall that has the new IKEA furniture. To visualize the black and white mask, you can press Alt and left click on the mask and it will become visible. If you want to turn the mask off temporarily, you can press Shift and left click to disable and enable it. You can see this white area is where I've painted, and when I return to the rendering, it's the only area of the rendering being shown. You may have to do slight adjustments to brightness, contrast, or saturation to blend the rendering into the photo more seamlessly. And now you have a before and after comparison showing what removing these desks and replacing them with a real 100% accurately scaled IKEA product would look like. I think this is a super useful skill to have and something worth practicing. I'm often asked to place fixtures and products, not always IKEA, into scenes, and most websites will have everything you need to recreate their products digitally. Sometimes they'll even have their own 2D drawings or 3D models already available for use. You can use this workflow to build a nice asset library of real scaled furniture and fixtures. You can use it to quickly populate your scenes for finishing touches, or to help accurately visualize a before and after comparison of a construction project, like a remodel to an apartment for yourself or a client. So to recap, in this video you learned how to use FSpy, Blender, and Photoshop to model a piece of IKEA furniture and visualize it in the photo of an existing office. We've covered a variety of techniques to combine an accurately scaled digital model with a real-world photograph. There are a lot of practical uses for this skill if you're an architect or an interior designer. Please feel free to leave a comment if you have any questions about any part of the process. I'd be happy to elaborate. I'm Andrew, and this is my 3D POV. I've used Blender as a professional architectural designer for years. If you have any requests for topics that you'd like for me to cover, say hi and leave a comment below. Thanks for watching.